pglake is an open source Postgres extension for querying data lakes and building interoperable lakehouse architectures with Postgres. You can use it to work directly against raw data in cloud object storage, as well as for building standalone lakehouse systems that support fast queries and transactions on Iceberg tables. Let me show you how easy it is to get started with pglake. I have several Parquet files in an S3 bucket, and I'm going to use pglake to work with them. I'm in the terminal, and I've already connected to my Postgres cluster. The first thing I'll do is run create extension pglake cascade. This will install pglake in my Postgres environment just like any other extension. Next, I'll create a foreign table from the Parquet data in the S3 bucket. I'll type create foreign table customer data. On the next line, I'll type server. And for the server parameter, I'll pass in pglake as the argument, which will let me query the external Parquet data. And finally, I'll pass in the path to the data I want to query. The cool thing about setting up this foreign table is that once I set it up, Postgres will talk to it just like any other table in the database. Let's quickly take a look at what was created. I'll type /d customer data. Here we can see the details of the table as well as the column definitions. And my favorite part about creating this table is that I didn't need to provide the column definitions. pglake automatically inferred the columns from the Parquet files. Okay, let's count the rows. I'll type select count star from customer data. That was pretty fast for 1.5 million rows. pglake embeds a vectorized query engine for fast columnar querying. Okay, that was really fast and easy. Let's step it up a notch. Let me show you how to create and modify Iceberg tables directly in Postgres with full transactional guarantees. We're going to keep working with the same Parquet files in our S3 bucket. The first thing I'll do is create another table and name it customer_data_tk. It's really easy to specify this table as an Iceberg table with the using Iceberg syntax. Finally, I'll create this table from the data in this file. And now I have an Iceberg table built from that Parquet data. Let's quickly inspect the columns and take a look at what's there. Okay, that looks good. If I want to find out the location of the metadata for this Iceberg table, I can query the Iceberg tables view in my Postgres environment. I'll run this query. The value in the metadata location column tells me where that metadata is located. Pretty cool. Now I'll run a simple update on the table. I'll delete some rows. First, let's get the count of rows. We're going to delete all rows where C_MKT segment is equal to furniture. This shows me that there are about 300,000 rows that match. Next, I'm going to run my delete statement. And finally, let's get the count of rows once more. And we can see it was properly updated. There are tons more things that you can do with pglake, like copying data to and from cloud object storage with JSON, CSV, and Parquet formats. Check out the docs that I've linked in the description and quickly get started building your open Iceberg lakehouses with Postgres. Thanks, and I'll see you next time.